What's going on, everyone? Welcome back to Dennis Simplifies. In today's video, we are going to go through diode analysis. So sit back, relax, and let's simplify. In the circuit below, V1 equals 22 volts, V2 equals negative 10.6 volts, R1 equals 42 kilo ohms, R2 equals 98 kilo ohm, and R3 equals 43 kilo ohm. Assuming the diode in the diagram below is ideal, calculate the value of the current I. Leave your answer in 4 decimal places. So as you can see here, we have the circuit diagram. V1, R1, the node B, R2, an earth portion, and then we have our diode here, which is going to be short circuited because it is ideal. So you're going to take it away. Let me put it that way. And then we have our 3 kilo ohm here. We have an I and then V2, a current I which is pointing in this direction, and then we also have V2. Now, anytime you are given a diagram like this, the best way to solve it is to redraw the diagram. That is, when you redraw it, it simplifies the whole thing for you. So what I'm going to do next in this video is to simplify this diagram to make it solvable and understandable. All right. So as you can see here, I have simplified the diagram, which is going to help us understand and solve this problem. So we have V1 equals 22 volts. We have R1 here, the B node, R2, an earth portion. We have R3 and the current I, which was moving in that direction. V2, which was equal to negative 10.6 volts. So if you look at this diagram that I've redrawn clearly, you can see that our bar moves from the highest voltage, which is 22, and ends at the lowest, which is negative 10.6 volts. And then this earth portion with its resistor R2 are kind of dividing V1 and V2. If you can see that R2 and this 0 ohm, 0 volt voltage is dividing V1 and V2. So in order to know the voltage at VB, which is the B node, we are going to use the voltage divider theorem to find the voltage that is being divided here at VB. So from the voltage divider theorem, we know that the point VB, which is the dividing voltage, is going to be V1 times the dividing resistor divided by the sum of the dividing resistor and the first resistor. So let's take it this way. So the voltage divider theorem. So the voltage at B equals V1 times the dividing resistor R2 divided by R2 plus the first resistor, as you can see. So it is the dividing resistor divided by R2 plus the first resistor. We know our values already, so we input them into our equation and we find VB to be 15.4 volts. I hope all is clear. Now, let's move to the next part of the question. Now, we want to find the value of the current I. Since we know the voltage at point VB and we know the voltage at point V2 to be negative 10.6 volts, and we also know the resistor at R3 that the resistance is 43 kilo ohm, we can actually find the current I, which is passing through the resistor R3, which is going to be VB minus V2 divided by R3. So finding current I, you're going to see VB minus V2 equals the I times the R3. We make I the subject and then we input the values and then we get the value for I to be 0.60465 milliamperes. Alright friends, that is the first question. Now let's solve another question. Assume the diodes in the circuit below are ideal. Let V1 equals 21 volts, V2 equals negative 5.6 volts, R1 equals 80 kilo ohm, R2 equals 61 kilo ohm. What is the value of the voltage at node B? As an aside, you will also want to calculate for the values of the current I1, I2, and I3, even though the question is only demanding for VB. As I said earlier, anytime you have a diagram this way, you may want to simplify it to make the computations and the understanding of the question easier for yourself. So what I'm going to do is that I am going to simplify this diagram here. So as you can see, I have simplified the diagram, which will make it easier for us to compute for our values. So you can see V1 equals 21 volts, R2 equals 61 kilo ohms. We have a current I1, a current I2, a resistor R1 equals 80 kilo ohms. We have an earth voltage at 0 volts, a node VB. We also have I3 pointing in this direction, and then V2 to be negative 5.6 volts. Now, one thing you realize is that we have this earth voltage and this resistor R1 dividing the voltage V1 and V2. You can see it is dividing them into two. So anytime you have this happening and you want to find the voltage that is being divided, that is the dividing of this voltage at VB, you want to use the voltage divider theorem, meaning we are dividing the V1 and then the V2. So to find VB, we are going to use the voltage divider theorem because it is dividing them. So using the voltage divider theorem, we know that the point VB equals V1 times the dividing resistor, which is R1, divided by R1 plus R2. We are going to input our values and we will know that VB is equal to 11.915 volts. Again, we are not done yet. We want to find the current I1. Since we know the voltage V1 and the voltage VB, and we also know the resistor R2, which is 61 kilo ohm, we can find I1 by subtracting V1 and VB and then dividing it by R2. So finding I1, we can see V1 minus VB equals I1 R2. Then we have I1 being the subject, V1 minus VB over R2. We input our values and we find I1 to be 0.1489 milliamperes. Next, since we still know VB, that is the dividing voltage, and we also know R1 to be 80 kilo ohm, and we know the voltage to be 8 over here to be 0 volts, we can find for I2. So finding for I2, we see VB minus the 0 volts over here equals I2 times R1. So we make I2 the subject and we input the values we know already. We're going to get I2 to be 0.1489 milliamperes. Good. Now that we know our values for I1 and then I2, we can go on to find I3. If you have noticed, you can see that there is no resistor between point B and the voltage V2. So how do we find I3? From the Kirchhoff current laws, we know that the algebraic sum of all the currents in the circuit must be equal to 0. We can see that I1 is pointing towards the node B, so it is positive. I2 is pointing towards the node B, so it is positive. But I3 is pointing away from the node B, which makes it negative. So we can say that I1 plus I2 minus I3 equals 0, since the algebraic sum is 0. So from Kirchhoff's current law, I1 plus I2 minus I3 equals 0. When we make I3 the subject, we are going to get I1 plus I2. Since we know I1 and then I2, we can input the values and then find the value for I3, which is going to be 0.2978 milliamperes. Alright friends, so that brings us to the end of our video and our session on diode analysis. If there are any questions, leave it in the comment section. My name is Dennis. This is Dennis Simplifies. Make sure you give a like and subscribe. Until next time, Apatia.